let's focus on what are ways to increase the rate of dissolving and how do you read a solubility graph. So first, if I have a sugar cube in water, what are 3 things you would do to get that sugar cube to dissolve faster? So a couple of things you might be thinking of, well, I would crush it. Absolutely. Crushing it increases the surface area that's exposed to the solvent, allowing it to dissolve faster. Something else, you might use a hot solvent or hot water instead of cold, because in a hotter temperature solvent, it's going to dissolve faster. And then the last thing is, when you drop that sugar cube in the water and you stare at it, you're really not going to be very patient, and so you'll want to agitate the solution or stir it so that you can get it to dissolve faster. So there are 3 factors that affect the dissolving rates of solids or liquids in a solution. Agitation, stirring or shaking, it brings fresh solvent into contact with the solute and increases the rate of dissolving. Surface area or particle size. Smaller pieces increase the surface area, exposing it to more solvent. So more surface area or smaller pieces would increase the rate of dissolving. And then heat increases the kinetic energy of the solvent molecules, so more frequent collisions between the solvent and solute, the faster it'll dissolve. So adding heat or a higher temperature increases the rate of dissolving. Doing these 3 things will increase the solute solvent contact with each other, which would make things dissolve faster. Stirring it or agitating it, crushing the particles, increasing their surface area and exposing them to the solvent, and adding heat so the particles collide with each other faster, causing them to dissolve faster. Solubility is going to be the amount of solute that can dissolve in a given amount of solvent at a certain temperature. So what this means is it's how much you can dissolve of a substance in a solvent. Different substances have different solubilities. Factors affecting solubility for solid and liquid solutes, there are 2 of them that affect how much solid or liquid you can dissolve in a solution. First is going to be the nature of the solute and the solvent. Like dissolves like. Is it polar? Is it nonpolar? Is it ionic? So that's going to determine first whether or not the dissolving will happen to begin with. And then secondly, the temperature of the solvent is going to play a role. If you increase temperature, in general, it will increase solubility of your solute. Agitation and surface area only affect how fast you can dissolve your solute. It does not affect how much solute can be dissolved. So factors affecting the solubility of a gas are totally opposite of those affecting the solubility of a solid. So if I wanted to increase my sugar cube dissolving, I'm going to heat up the liquid, or I'm going to increase the surface area, or I'm going to stir it. You will do utterly the opposite when it comes to gases overall. So for a gas, if you have a high temperature, it's going to decrease the amount that'll stay dissolved. And if you have a colder temperature, it's going to increase the amount of gas that can be dissolved. The solubility of gases and liquids decreasing with increasing temperature. Warm soda pop fizzes more than cold soda pop because the solubility of the dissolved carbon dioxide gas decreases with increasing temperature. So if you have a cold soda, the carbon dioxide will more likely stay in the solution, but if you have a warm soda pop, then the carbon dioxide more likely will bubble out of the solution. Pressure above the liquid affects how much gas can be dissolved in it as well. If you have a high pressure above the liquid, it increases how much gas will be dissolved. And if you have a low pressure, it decreases the amount of gas that will be dissolved. So you can see in the diagram over here that the solubility, if you increase the pressure, then you'll see how it pushes more of the gas into the liquid. Cans, bottles of Coke, you want them cold and under a high pressure in general to keep the carbon dioxide in the liquid. Consider this example of lake water. If the water gets too hot, it cannot dissolve as much oxygen gas, in which the fish may die. So you'll notice during the day, as the sun comes out and the water gets warmer, the oxygen content gets lower and lower, and so fish have to dive down to colder waters lower in the lake in order to have more oxygenated water. So why are sodas from the refrigerator more carbonated than those that are not refrigerated? And it's because as you decrease temperature, cool down the liquid, you increase how much gas can be dissolved.